Hello friends, I am Dr.V Deshpande, Department of Physics, Shivaji Arts, Commerce and Science College, Kannad. Now today we discuss about the applications of Gauss law. In this application, now electric field intensity due to a line of charge or uniformly charged cylinder. Now for this purpose consider a cylinder of an infinitely long rod. Charge density is lambda. Let there be a point P at a distance r from the rod where the electric field intensity is to be calculated. We choose a right cylinder of radius r and length L coaxial with the rod as the closed Gaussian surface. The contribution to the flux due to circular ends of the cylinder is shown by the figure. Comes out to be 0 because E and ds are at right angles to each other. Therefore, E dot ds, that is equal to E dot ds cos 90, and value of 90 is 0, cos 90, therefore it is 0. The only contribution to the electric flux is due to the curved surface of the cylinder. Because of symmetry, the magnitude of electric field intensity will be the same at all points of the curved surface of the cylinder and is directed radially outward for this surface. E and ds are along the same direction. That is, the angle between E and ds is 0. If we take a small element of this surface, the electric flux will be E dot ds is equal to E dot ds cos 0, and value of cos 0 is 1, therefore which is equal to E dot ds. The total electric flux due to the entire Gaussian surface is given by phi E is equal to integration over closed surface E dot ds, and this integration over dot ds is 2 pi RL. Now according to Gauss law, this E into 2 pi RL is equal to Q upon epsilon naught, which is equal to lambda L upon epsilon naught. As lambda is charge per unit length, and for the length L of the rod, charge Q enclosed is lambda into L. Therefore, E is equal to lambda L upon epsilon naught in bracket 2 pi RL, which is also equal to lambda upon 2 pi epsilon naught R. The direction of E is radially outward for line of positive charge. Now, Poisson's equation and Laplace equation. Now consider electric field is the gradient of scalar potential. E is equal to minus of del dot V. Now fundamental equation of E is divergence of E is equal to, that is, del dot E is equal to rho upon epsilon naught, and curl of E is equal to 0, that is, del cross E is equal to 0. Now del dot E is equal to del of minus of del V, that is, del dot E is equal to minus of del square V. Now del square V is equal to rho upon epsilon naught, where rho is charge density. This is known as Poisson's equation. If the charge density is 0, that is value of rho is equal to 0, then this equation del square V is equal to 0, and which is known as Laplace equation.